We've got an important video here. This video is going to introduce and define our 6 trigonometric functions. So let's consider some angle theta in standard position. So standard position means that its initial side coincides with the positive x-axis, and then its terminal side is, well, somewhere else. So here I have it in the second quadrant. And I'm going to choose some point, call it P, on this angle. And since it's some point on the Cartesian plane, we can write that as the ordered pair xy. Well, we can drop a perpendicular from this point down to the x-axis that intersects at some point. We'll call it Q. This also creates a right angle for us. If we wanted to calculate the distance, I've labeled it R, between the origin and the point, we could do that using our distance formula. Right? D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, where the origin is the point 0, 0, and then we have our other point xy, so plugging that in, that's where they're coming up with this. And then that simplifies down to just be the square root of x squared plus y squared. So R is going to be the square root of x squared plus y squared. That's going to be important for us. Another way that we could look at that value of R is we could look at the fact that we have a right triangle here. And when you have a right triangle, Pythagorean theorem applies. R squared would be equal to x squared plus y squared. And then we take the square root of both sides, bringing us to the same conclusion that R is equal to the square root of x squared plus y squared. I probably think of it more with Pythagorean theorem than I do with distance formula. Okay, so here are our super important definitions that we absolutely need to know. We're going to let xy be some point other than the origin on the terminal side of an angle theta in standard position. The distance from the point to the origin is r equal to the square root of x squared plus y squared. The 6 trigonometric functions of theta are defined as followed. And again, absolutely have to know these. This first function is abbreviated sin, but it is said sine. That's the full name. So sine of theta is equal to y divided by r. The next one, abbreviated cos, this is cosine. Cosine of theta is equal to x over r. TAN is abbreviation for tangent. Tangent of theta is equal to y over x, where x is not equal to 0, because if x was 0, we'd have a 0 in the denominator, and that would make our function undefined. The next one, abbreviated CSC, is cosecant. So cosecant of theta is equal to r over y, where y isn't equal to 0. So again, we've got that concern about it being undefined, so our denominator can't be equal to 0. Our fifth function, abbreviated SEC, is secant. Secant of theta is defined to be r over x, where x is not equal to 0. And then our last function, this is cotangent. Cotangent of theta is equal to x over y, where y is not equal to 0. Oh, right away, there's two things that you want to start studying. First, what these are called, right? Like what the real names are, because we don't say cos of theta and tan of theta or cot of theta, right? We say these whole words. So the first thing you want to do is just practice what these abbreviations stand for. And then the second thing you need to study is all of these. All of these definitions we have to know for all of right-angled trig, that sine is equal to y over r, secant is equal to r over x. We got to know all of these. Now, something to help you remember, because I always pair them up in the same way. Sine, cosine, and tangent are our main three. We use those three trigonometric functions far more than we use the other ones. So I always, put them right in a row. And then you may have noticed with these definitions, the way I have them paired up, that these are all reciprocals of each other. So I kind of try to always pair them up and know which ones are reciprocals of each other, because then if I know the definitions for sine, cosine, and tangent, then I automatically know the other definitions because it's just the reciprocal. In subsequent videos, we'll see how we can use these trigonometric functions.